In this tutorial, we'll look at how to use HydroCalc to calculate peak runoff and develop hydrographs for multiple subareas at once using a formatted CSV input file. This workflow is especially useful for projects with many drainage subareas or situations where you need to evaluate multiple design storms for the same subarea. Just like in the previous tutorial, HydroCalc applies the modified rational method in accordance with the Los Angeles County Hydrology Manual. When analyzing one subarea, manual input works well. But for larger projects, entering data one subarea at a time can be time-consuming and error-prone. A CSV file, or comma-separated values file, is a text file used to store data in a table format. Each line is a row, and each value in that row is separated by a comma, which functions as columns. It is simple and universal format for moving data across different computers and programs. They can be edited with simple text editors like Notepad or with spreadsheet software such as Microsoft Excel or Google Sheets. The CSV input option allows you to define multiple subareas in a single file, quickly test different design storms, and maintain consistency across inputs. Let's take a look at the required CSV format. Each row in the file represents one HydroCalc run, meaning one subarea and one design storm. The columns correspond directly to the standard HydroCalc inputs: project name, subarea name, area size, flow path length, flow path slope, 50-year 24-hour rainfall depth, impervious rate, soil type, and design storm frequency. It's important that the column headers and units match HydroCalc's requirements exactly, or the file may not import correctly. One common use of CSV input is to analyze multiple design storms for the same subarea. In this case, you simply include multiple rows with identical physical parameters, but different design storm frequencies. For example, a single drainage area might be analyzed for the 10-year, 25-year, and 50-year storms to meet different design criteria. If you intend to export the results in a CSV format as well, it is recommended to include the design storm in the subarea name. For example, a subarea entry can read Subarea A1 10-year in one row, and the same subarea can be named Subarea A1 25-year in a different row. This will be useful in a later step. Once your CSV file is complete, open HydroCalc and select the Multiple Subarea tab at the top. Then click the Import CSV option to open a File Explorer screen. From there, navigate to the file location where the CSV file is stored and choose the CSV file. After selecting the file, HydroCalc will display the contents in a table. Here, you can review that the correct information is presented in the corresponding rows and columns. With the CSV successfully loaded, you have the option to export a PDF report with the results for each subarea entry, or a folder with multiple CSV files, one for each subarea entry. HydroCalc will compute for each subarea entry the time of concentration, peak rainfall intensity, peak flow rate, runoff volume, and the corresponding hydrograph. When using CSV outputs, this is where it is important to include the design storm identifier in the subarea name. HydroCalc will overwrite CSV files if multiple runs use the same subarea name, even if the design storm is different. Clear naming conventions help prevent lost data and ensure separate CSV files for each subarea entry. Each output file contains the calculated hydrologic parameters and can be reviewed using a simple text editor or spreadsheet software. Using CSV input in HydroCalc is an efficient way to handle large projects and multiple design storms for projects within LA County. When using this method, remember to double-check CSV formatting, use clear subarea naming conventions, and select design storms appropriate for your project requirements. Thank you for watching, and this concludes our tutorial on batch processing with HydroCalc. If this tutorial was helpful to you, please leave a like and subscribe. I will be uploading future videos on this and other hydrology or engineering software.